Welcome to Brain Vision.
In this problem, we're going to draw the phase diagram for argon. So based on the information provided to us, we can go ahead and label the phase diagram that I already went ahead and drew out. So on our x-axis, we have temperature, which I went ahead and put in degrees Celsius, like given to us in the problem. And on the y-axis, we have pressure, which I would put in ATM, like given to us in the problem. And so looking at this diagram, we can kind of reason through the sectors, how they get labeled. As we know, at a higher temperature and a lower pressure, we would be in the gas phase, as you can see over here. And then as the temperature rises and the pressure stays relatively, as the temperature remains high and the pressure starts to increase, we would see that we transition into the liquid phase. And then as the temperature begins to decrease and the pressure stays pretty high, we go to the solid phase. Okay? So going ahead and labeling this, we can look at our normal melting point. Normal meaning it's at standard pressure. So standard pressure is 1 atm. So we can go ahead and label that for the melting point. We'll put 1 atm right here. And we're going to go ahead and do the boiling point. So I'm just going to go ahead and extend that line. So this would be 1 atm. Sorry, 1. Okay. And then for our boiling points, we can label the temperatures. So we would go all the way down. So this would be our melting point, and then this one's going to be our boiling point. And so they give us both those numbers. Our melting point is going to be negative 187, while our normal boiling point is going to be negative 186. And again, we're going based on sort of a standardized diagram that I already drew out, so this isn't completely drawn to scale. And so then they also go ahead and give us our triple point, which is right here where all the phases exist simultaneously. And so that will be at negative 189. So we can write that in. And they also go ahead and give us the pressure that they put that at. Oops. And so we'll go ahead and write that one in too. So this would be negative 189, squeezing that in there. We'll move this one over and get that under the line. Oops. There we go. And then this would be at 0.68 atm. Okay, and then they also give us data for the critical point, which is up here where the gas can't exceed in normal circumstances. And so that one would occur at negative 122 and 48 atm. So we can go ahead and write those in as well. And so after we've labeled everything, you can basically reason through any of the phase transitions that you would need for argon, and it will give you accurate detailing of the parameters surrounding those phase changes. Thank you.